First of all, I want to use this chance to thanks again, especially ADBI and Professor Cizeron and Professor Hayashi to invite me here to give a talk about high-speed rail in China. And I think this is a great seminar because we not only talk about research, but also I notice many of the audience are from the enterprise and from the planning companies and even from the maybe government. So we can use this chance to exchange the ideas and knowledges, and which could be very beneficial to improve our research. And my talk is about the development and the social environmental impacts in China. And I will talk in the following sequence. Firstly, I will briefly introduce the development and the current status of high-speed rail in China. And secondly, I will introduce some facts and some research regarding the high-speed rail socio-economic effects. And thirdly, I will talk a little bit more about its environmental and ecological impacts. And finally, I will summarize the research and propose some implications for the future development. Firstly, as you know, that China's high-speed rail system was not so long history. It just was developed in nearly just 10 years ago. The first line was built between the capital Beijing and Tianjin in 2008. And then afterwards, several other lines like Wuhan-Guangzhou, longest line at that time, in 2009, and the Beijing-Shanghai line in 2011, and the Harbin-Dali line, which is connecting the northeast parts of China. And those lines, several of those lines was have the records, world longest records during that time of construction. And currently, the high-speed rail system, the spatial pattern was shown these two figures. On the left side, it shows the current spatial pattern. We called 4 vertical line and 4 horizontal line, and that was planned during the 2008, just beginning of the high-speed rail system. After 10 years, around 2016, all of the network of the whole China's high-speed rail system in the spatial was expanded, or we can say extended, just doubled, from the 4 vertical and 4 horizontal to 8 horizontal and to 8 vertical lines. And in addition to the spatial expansion, the length of the whole high-speed rail system was also expanded or extended significantly. Currently, the length of China's high-speed rail system in operation was about 25,000 kilometers in 2017. It was about 2/3 of the whole world's high-speed rail system. And to say about its speed, the average speed of the China's high-speed rail was about a little bit higher, faster than 300 kilometers per hour. But for the fastest one, which was in operation last year, we call the Fuxing Bulletin Train, its speed was reached to 350 kilometers per hour, and it hits the fastest record in the world. And accompany the development of the high-speed rail, I think it brings a lot of changes, and among those changes, the ticket also is an interesting change. Like in the foundation, just after the foundation of China, New China, around the 1940s to 1990s, we used the small tickets. And afterwards, after 1990s, we used a little bit bigger paper ticket. But after 2007, we just make some reform. We use a paper one, but with a magnetic bar embedded inside. And after 2011, we just abandoned the paper tickets. Now we can just use our personal ID card, just smash on the entrance, and then we can just take the train. It make the system more smooth and even friendly to the environment. Of course, this change is another biggest change and biggest impacts is about the station around the regional development around the station, high-speed rail station. And this figure shows the Shanghai railway station, the old station in the 1980s, and after the opening of the high-speed rail after the 2000, you could see there is a very obvious development between before and after this opening of high-speed rail, and the whole system the whole region was become so popularized, full of high-rise buildings and very wide roads and a lot of commercial facilities there. And of course, it will improve the travel comfortableness of the passengers. And the time saving is also very obvious. If you take the train from Shanghai to Beijing, it only costs, according to the fastest Fuxing bulletin train, you only cost 4 hours and around 40 minutes to get Beijing. But at the same time, when we get benefits from this high-speed rail development, we also generate some side effects accompany the high-speed rail development. Like people are more concerned about their health, which is due to the radiation problems. And the people living or walking around this station, they are complaining about the noise disturbance. And because of the bigger station, land occupation is also a big problem. And it will also generate the over-agglomeration of the economy and the population in some mega cities, which means bigger city will become bigger and bigger, and the small city will shrink and maybe die in the future. So, around when we're talking about these changes which high-speed rail just bring to us, we want to focus on the following 3 questions and want to try our best to answer these questions. First is, which part of the social environmental aspects that high-speed rail may affect, and to what extent high-speed rail may contribute to those impacts, and finally, what are the implications for the future development. And for the socio-economic effects, as I mentioned above, that just before and after the introduction and opening of the high-speed rail, it brings so many changes to people's life. Like according to a survey between the Beijing and Shanghai's line, over 63% of the people, they said they will choose high-speed rail as their first choice for the medium to long distance travel. That means the travel just within the 5 hours or around 1,000 kilometers, high-speed rail will be their first choice. And according to another survey, just still in the same line between the Beijing and Shanghai, and asking the people, what are the most important impacts to your daily life? And the people choose that tourism and employment and their visit to the relatives and friends are the most significant and most important impacts which is brought by the high-speed rail system. And interesting, there is another survey. They're asking people that they do a lot of surveys and a lot of questions, but one problem is about their attributes of those samples. People will get interviewed. That most of the people get interviewed, when you're looking at their income, you will find majority of these passengers get interviewed who take the high-speed rail. Their income was belong to the middle and higher or upper class income level, which means over 60% of the people are their annual income was above 60,000 Chinese yuan per year. And this is a quite interesting social problem, and later I will discuss later. And to discuss about the accessibility change, this is obvious, not only in China but also everywhere in the world. When you are operating or when you are opening the high-speed rail, it will definitely increase or improve the regional accessibility. And this is a map shows the Yangtze River Delta region in China, which is the largest urban cluster or urban agglomeration region in China. And Shanghai is here. Shanghai is here. And in the north part is Jiangsu province, and in the south part is Zhejiang province. And you will see the left side, the figure shows the accessibility that without high-speed rail. And the right side shows the map, the accessibility with high-speed rail. Definitely, the regional accessibility was greatly improved as the red color extended nearly to the whole region. And you will see that in the left side, the blue color means the low accessibility. This still exists, and they are mostly located in the south parts of the region or north parts of the region and some coastal parts. And those areas was totally have no service of the conventional train or conventional railway services. But after the introduction of the high-speed rail, those blue colors areas shrink. Very obvious. And next, this shows that the accessibility can be measured by several indicators, and this shows the access time from the city center to the railway station. And the blue bar shows access time, average access time from the city center to the main high-speed rail station. And the red curve shows the access time from the city center to the conventional or old railway station. So what do you find? What do you find through this figure? You will see there is a big gap. For example, when we look at the where is Shanghai? Shanghai is here. You will see the red car is here. That means the access time to from the city center to the old or conventional railway station is around less than 5 kilometers. But if you go to the Hongqiao, the new high-speed rail station, it doubled, more than doubled of its access time. And this phenomenon almost can be found everywhere in the cities along the Yangtze River Delta region. And that means most of the high-speed rail stations, they are newly built. Most of them are newly built. This is totally different from European countries' case. European countries' high-speed rail system usually was upgraded on their old or conventional station. They just introduced the new bulletin trains into their station. But China, they want to develop new towns and new villages, so they build as Professor Pan has already introduced, they want to build a new city. So most of the high-speed rail stations was located far from the city center. And most of these areas was left behind of the development. But we still have some evidence that there is lots of problems, but their benefits was very obvious. When taking a case of the Beijing and the Tianjin line, you will see this is a small district located in the Tianjin city, Wuqing district. And this district was opened and built as a station, high-speed rail station. And this figure shows the GDP growth rate of this district during the last more than 10 years. And this vertical line shows the opening year of the high-speed rail. You will see this GDP growth rate was significantly jumped up level due to the opening of the high-speed rail. And more than of the GDP growth rate, the passengers flow into this Wuqing district also increased very fast at an annual growth rate of 20%. And the number of trains just stop at the Wuqing station also increased from 6 to 20. This is a very big jump. But all of these facts are from some statistic numbers and from some figures and from some curves. But what exactly the high-speed rail could infect the economic organization and economic structure. Nobody knows, or the knowledge is quite limited. So, about 6 years ago, Professor Hayashi and me, we developed an empirical model. And this model, although it's based on the statistical regression analysis, but we regard it as a very useful tool, could help us to understand how the high-speed rail could affect the industrial location choice. And through a stepwise regression analysis, we just choose 3 important variables to explain the industrial location choice. Here, industrial location was defined as the employees, the number of employees of an industry in an area. And this employees number can be explained by 3 basic factors. One factor is the interdependence between the industries of one area and its neighboring areas. And the second factor is the consumption demand from the neighboring areas to the on the products and the services. That means how many products and how many services can I get from the neighboring areas, neighboring cities, or neighboring counties, or neighboring prefectures. The third one, we think, the accessibility, of course, access time is also important to the location choice. If this figure becomes bigger, that means there is no efficient services of the rail or high-speed rail, and it will affect the people's accessibility or people's ability to get the location of the industry, enough necessary industries. And I will skip the detailed explanation of definition of each variable, just as you give you a brief idea that the industrial interdependence means, just as this figure shows, if I'm living in this prefecture, taking a Japanese case as a case, if I live in the prefecture I, so how many industries we have the relationship with prefecture I, and each industry in different prefecture, their connection to this prefecture, center prefecture, their correlation are different. Some have very strong connection with this prefecture, while some are very loose connections. So this inter-D, we define it as average interdependence of prefecture I, how they can interdependent relationship with neighboring cities or neighboring prefectures. The second one is the consumption demand, which means the more demand there exists, more I can get, more industries we need to locate it in this area. This is quite obvious. And the third one is access time. The smaller this value is, that means the more accessibility we have and more convenient we can get the services. So, though we don't have enough data to time to apply to the Chinese case, but we apply this model to a Japanese Shinkansen system, and we use the data based on 3 levels: the country level, prefecture level, and the city level, and choose the year 1990 and 2000 for case study. The number of employed persons, their trade between the transactions values and the value inputs, labor inputs between industries, 11 industries and the prefectures, and the city's access time to the railway system was also calculated. So the results show that, as an example of the result, this network shows the interdependence between different industries. For example, construction. The arrows here shows how strong this industry was connected with other industries. If this arrow was out, that means real estate and electric power and gas and water supply, these 2 industries was heavily relied on the construction sector. On the contrary, if the arrow was into that sector, for example, steel, construction, that means services, and commerce, and transport, and communications. They contribute a lot to the construction sector's development. And using a cross-sectional regression model, we just separately analyze 11 industries in different years, how they contribute to the employment numbers change. It was found that in the 1990s, the most important factor was the interdependence between the industries. Their elasticity was ranged from the 0.7 to 0.9, which means with 100% of the change of the industrial interdependence, nearly 70% to 90% change will happen due to this change to the employees numbers change. But when we move to the 2000, the dominant factor was changed from the interdependence of the industry to the consumption demand. It's quite easy to understand that people's consumption demand, the demand for goods, services, and demand for good products, they affect the employees' number change more significantly. And the access time in 1990 and 2000, although their elasticity is not so higher as those two factors did, but it still has some implications that with the change of the elasticity, for example, the manufacturing, this elasticity become larger here, and many of them become larger. Construction 0.07 to 0.9. That means the access time was greatly improved due to the construction of high-speed rail, and it has a chain effect to the employees' number change, which means the industrial location choice was greatly influenced by the high-speed rail systems construction. And to make the result more understandable and more easy to see the change, we took the Hokuliku line as an example. It was built in 1997, and it was there are 4 stations within the Nagano prefecture. And due to the construction of high-speed rail, definitely, and the access time or the accessibility of this prefecture, Nagano prefecture, was greatly improved. That means their access time was decreased. Then what happened? When we see the employees' number change in 1990 and 2000, you'll see these top 4 or 5 sectors, their number change was very significant. For example, real estate, their increase rate about 2.7% a year. And for commerce, their employees' number change was about 1.1% a year. This is greatly proved by our model. Then, what happened to the high-speed rail's environmental impacts? According to a survey, another survey, but this survey is not only to the Beijing and Shanghai's railway line, it's to many, around 1,000 questionnaires and 1,000 samples of the people, and asking people what's their perception on the environmental impacts to you if you fear that high-speed rail system may generate. What's the result? The top 3 concern of people's concern about the environmental impacts is ranked as this. First one is accident. The second one is land occupation. And third one is noise disturbance. You see that people not, when comparing with these top 3 concerns, like water and soil erosion, water pollution, air pollution, these typical and traditional environmental problems were not so problematic, were not so important to the local people. But Japanese may ask why the accident could be a problem, because in Shinkansen, during the last 60 years or 70 years, there's no fatal accident at all. But in China, we have one. In 2011, there is a very serious accident in Wenzhou, and the high-speed rail just ran out of the rail and killed 40 people, and hundreds of people get hurt. So that's why Chinese people, when they take the high-speed rail, the first concern is whether it's safe or not, whether this accident will happen again or not. So this is a different case, different story. And if we look at the life cycle environmental impacts of the high-speed rail system, and we categorize the environmental impacts into 7 categories. For example, the acidification potential, and the Chinese biotic depletion potential, and primary energy demand, to the air pollution problems. You will see that in the life cycle of the high-speed rail system, the vehicle operation stage, they contribute nearly 72 to 91% of totally 5 categories environmental problems. And this is very easy to understand because in the current stage, most of these environmental problems was come from the electricity use. And electricity is not so clean enough because all of the electricity was based on the coal-based power generation. So it will generate SO2, NOx, or greenhouse gas, or PM 2.5. And another stage like vehicles maintenance, manufacturing, disposal, and infrastructure construction. It contributes greatly to the Chinese biotic depletion, like a coal. If we all transfer all of these biotic resources into a coal, it finds that it contributes to nearly 80% of these environmental problems. And if we normalize all these 7 environmental impacts into one standard, into one criteria, you will see that the Chinese biotic depletion potential and primary energy demand and acidification potential totally generates as the top 3 environmental impacts of the high-speed rail system. And the vehicle operation contributes to over 60% of the whole overall life cycle environmental impacts due to its dominance in all of these categories. And vehicle manufacturing and maintenance, disposal, and infrastructure construction contributes about 20% of the total environmental impacts. And finally, I want to just make some summary of my talk and give some implications. And this statistic figures shows the rail density and rail passengers density in some countries in the world in 2015. The blue bar shows the rail density, which is measured by the length area of the territory. And you see, China is not so high, though it has the world's longest high-speed rail system. But when we talk about the rail density, it's not so high. When comparing with those very high stock countries like Japan, Germany, UK, and France, China's level was only about 1/8 or 1/10 of those developed countries. But interestingly, if we see the passengers density, that means how many passengers was using the high-speed rail per kilometers travel distance, you will see that China's passengers density was very high, just ranked the 3rd. The top one is India, and second one is Japan. But India and China's case was quite close. Japan's case is quite typical and very extreme. It's very special because you see Japan's rail density is very high in the world, and its passenger density is also very high. That means this gap was very small. But if we see the India's case and China's case, this gap, the blue bar and the red curves, their gap was very, very big. That means we are lack of the railway system. And the railway system's development was far behind the economic development. Another figure shows how the railway system, their service changed during the last 20 years. And what's the share of the rail service in the on-road system? This bar, the blue bar and the red bar, shows the railway system service. That means how many passengers was transferred through the railway system. You will see that there is 3 stages. After 2000 to 2003 or 2004, it's quite stable. This railway passenger turnover volume was very stable. That means the conventional train system, their capacity was over capacity. But after 2004, China issued a speed up campaign to the whole country's rail system. So the speed was lifted very significantly. So make the system services increase very fast. But after 2008, after the introduction of the high-speed rail, its increase was accelerating. And besides, when we see the share of the railway services, this black curve, this shows the percentage change. You will see that there, in the last 10 years, at the beginning 10 years, its share was decreasing. You know why? Because after 2000, people's income was greatly improved. Chinese people getting more rich and rich. Every family can afford to buy a car. So private car, their ownership was increasing very significantly. More people prefer to drive car instead of using public transport. So public transport, within that, the rail services was decreasing. But there is a big jump around 2012 and 2013. This is not some special phenomenon because of the method change of the statistics number. So can be ignored. But after 2003, when the method was stabilized, you will see there is slightly or stably increase of the services, and this can be largely attributed to the high-speed rails operation. So, what's the policy implications for the future development, not only in China but also in other countries, is we should examining carefully the role of high-speed rail system, especially the stations in the urban development. Because many previous studies, they have already pointed out that high-speed rail could polarize the regional economies. And the small cities would be further exploited by the central cities. The strategy, which is very popular in the China, that to promote the local property market and economic development through the construction of the new towns around the high-speed rail station, may not be effective everywhere. This is not a unique rule for all of the Chinese cities, because whether the high-speed rail new towns located far from the old city center in less populated area or cities can attract residents, attract business, is still questionable. The second one is we need some further studies on the transport inequality issues, which might be created by the high-speed rail the operation. Because, as already I introduced at the beginning, that according to the survey, the majority of the passengers using the high-speed rail belong to the middle to high-income classes. So whether the high-speed rail development may create a new dimension of the transport inequality or reduce the regional disparity, still a question, needs our further studies. The third one is about the empirical analysis and supporting data are needed to better understand high-speed rail's impact on China's economic organization. Because as I explained at the beginning, China's high-speed rail system was just introduced within 10 years, it's quite a new phenomenon. So everything, the accumulation of the empirical evidence is just starting. So the region and evidence-based analysis will be needed to enable to gradual calibration of the parameters used as a part of the quantification to better understand the high-speed rail's economic impacts in Chinese context. And the final implication is we need to, from the environmental aspects point of view, we should shifting our energy mix from the current status to a cleaner and renewable sources, like from the coal-based power generation system to a greener one, like using more renewable and clean energy, nuclear one, wind energy, hydropower energy, and solar energy. And this would likely to create a biggest environmental benefits in consideration of the dominant role of the vehicle operation phase plays in the life cycle assessment of the high-speed rail system. And that's all for my presentation. Thank you all.